AI applications have unique requirements for server infrastructure, so a new platform is required. At the same time, we have to start with the fundamentals. What does the user need? What does the application need? Instead of just thinking about what the technology can deliver. That's the subject of this episode of Utilizing Tech, featuring Mark Klarzynski of PEAK AIO, Jeniece, Wnorowski, and myself, Stephen Foskett. Welcome to Utilizing Tech, the podcast about emerging technology from Tech Field Day, part of the Futurum Group. This season is presented by our friends from Solidigm and focuses on AI and the edge and other related topics. I'm your host, Stephen Foskett, organizer of the Tech Field Day event series, including AI Field Day and Edge Field Day. And joining me from Solidigm as my co-host today is Jeniece Wnorowski. Welcome to the show, Jeniece.
Hi, Stephen. Thank you for having us. It's good to be back.
It is good to be here as well. And we have been focusing all season long on the sort of unique application requirements for AI servers, for edge servers, the fact that these are somewhat different than what we found in the conventional data center.
Yeah, and the world is pretty wrapped up right now around enterprise and all things, power and cooling, but it's really interesting to take a look at how are organizations deploying AI truly at the edge. And so we're delighted to have with us here today Mark Klarzynski from PEAK AIO, who's going to talk a little bit about the unique use cases that they deploy at the edge.
Welcome to the show, Mark. Why don't you introduce yourself quickly?
Thank you, Stephen, and hello, Jeniece. I'm Mark Klarzynski, PKIO. I'm the founder of PKIO, and I have the good fortune to have worked with Solidigm for a few years now, with a real focus on AI, predominantly in that incubations period and that edge case where it's developing more and more. And hopefully we can discuss some of those exciting and up-and-coming current and emerging use cases.
So, Mark, tell us a little bit more about PEAK AIO specifically. What is it that you're building?
So, Stephen, let me jump back a few years, pre-COVID, which we've almost forgot now. I've been in storage, as you can see, I've gone past the grey stage, and I've been in storage for 35 years now, and I was happily consulting within the NVIDIA channel at the time, and at this point, AI was beginning to take off. This is way before ChatGPT, and some of the early pioneers, which were the obvious use cases like healthcare, etc. They were moving ahead and pioneering some amazing projects, but the challenge was that while NVIDIA had made this new amazing ecosystem and this new market completely, the rest of the infrastructure hadn't really caught on. And so, the solutions were going out, but they were really not performing maybe quite as well as they should do, because everybody had really rebadged traditional IT products and turn them into AI branded products, but they weren't really working for a whole bunch of reasons, technical and use case fit. So we actually started PKIO when we realized that there was a need. This was not just a new market that was demanding a completely different level of performance and had a different use case. It needed a whole different range of ecosystems and infrastructure. Why would we expect data storage that's being developed for enterprise use to suddenly work in an AI use? That's completely the opposite. So we really focused on developing AI storage to accelerate the use case at the time. And we were really fortunate to work with some of those early pioneers in the healthcare and beyond to allow us to, for the first time probably in my lifetime in storage, where we didn't design something and then told the market what they needed. We actually listened to the market and got, hey, what is this new thing? And what challenge do you have? And the challenges were just so fundamentally different. We just simply started afresh, luckily enough to work with Solidigm, and we built from that Solidigm foundation upwards to deliver what they needed and exactly what they needed to achieve the best out of that AI roadmap.
So Mark, with that, thank you for that introduction. I just want to follow up and ask, so is it is it software that you guys do, or how is it that your solution is vastly different than others on the market today?
Yeah, it's purely software. Now, there's nothing necessarily new about software-defined storage, as we call it. What is different in our case is we took a step back and we said, hey, when we were making software-defined storage some 20 years ago, we had hard drives, we had 10 gig NICs, we had a bunch of 20-year-old technology. Today, we have amazing NVMe from you, we have amazing networking from others, and wonderful off-the-shelf servers that are, have the power that we would have only dreamt about. So in this case, what we did is we said, well, let's not take everything we know, let's just take everything that's available and put it together and get as close to that hardware as we can to make it work in a way that the user needs it. Nothing more. No smoke, no mirrors, just deliver exactly what the user needs. And the advantage of that one was that it's you know, a different level of simplicity, which is exactly what an AI user needs, because they're often a clinician, a doctor, a professor, a biochemist. They're not an IT specialist, but also that we're so close to the hardware that I'd love to say it was an amazing strategy, but that meant that when you guys brought out Generation 5, we just doubled in performance because we were basically taking what you delivered and making it usable. So that's what separates us. We take off-the-shelf hardware and turn it into hyperfast AI-focused data acceleration.
Now, when you say AI focused, and what exactly do you mean? I mean, is this for the big AI supercomputers in the cloud, or is this for your doctors and
Mhm.
engineers and so on in the field?
Originally, it was the doctors and engineers in the field. As AI has moved and projects have become more mainstream, then they are getting bigger and they're becoming more known. But one of the largest challenges, Stephen, actually, I mean, it's obvious when you know it. But if we just simply think about what we had before AI, what we had was an enterprise customer who may have 1,000 machines. 500 of them were probably mobile, laptops. Uh, 200 of them were probably workstations. 10 servers, an email server, database server. So thousands of connections, but from thousands of machines. None of them demanding ridiculous amounts of performance. Maybe one or two, but all of them just wanting a decent amount. On the opposite side, you had HPC, or still have HPC, that generally would have millions of cores over thousands of compute nodes. And so you've now got storage here that's delivering tremendous performance, but to millions of cores over thousands of networks. Whereas suddenly AI came along and NVIDIA said, well, hey, we've got 1 million cores on 2 machines. Well, we've never seen that. We'd never had one machine demand that much performance and be able to sort of basically take the entire performance of storage over a protocol. And just, we were able to deliver that, but generally in the past, that would be over so many machines. It was AI fundamentally changed the way we delivered data. And in the beginning, yes, to be fair, there wasn't the giant superpods that we see today. Everybody was learning AI, right? Nobody really knew what they were doing. They just knew they needed it. The amount of conversations I had that were saying, yeah, we're going down the AI path, and it would be, well, what you doing with, well, we don't know, but we know we need AI. And everybody did that. I think it was probably some years later before, it became obvious that there was a use case in just about every vertical. So really at the beginning, it was very much smaller clusters of 1 to what we call DGXs, HGXs, which are sort of the NVIDIA servers. And that would really be, a professor in his team or a company that was testing some AI projects, or even, a HPC company that was trying to work out how to use GPUs. And so they certainly were a lot smaller, but, they still demanded that amazing performance. So really the difficulty was we'd always had performance, The advantage we had was that we were able to deliver that to many machines, and it was aggregated. To suddenly have it demand and to be able to deliver it to one or two was really challenging.
Yeah, and you mentioned, Mark, being customer centric and really getting in with the customer and listening to what they have, what their challenges are. And I think you're right. Not everybody gets access to the big, DGX, servers. And let's be honest, who can get their hands on a GPU right now, right? So there's lots of challenges. But, your solution being that it's true edge, right? It has all that power that you mentioned of some of the big super pods, but you're putting it as close to the patient, if you will, and the physician in a hospital environment. So let's take like an MRA use case. Right? I heard you guys once say, someone coming out of that machine before they even tie their shoelaces are able to get their results. And tell us a little bit about what enables that. What does that look like?
Yeah, I mean, we were really fortunate that one of our first encounters in AI was with a large university in the UK called King's College London and associated universities, and they were really focused on what they called AI value-based healthcare. Because if you think about healthcare, there's an advantage at every level, to the patient, to the government, in our case in the UK, the National Health Service, the local authorities, to the insurance companies. There's an advantage in diagnosing or providing a better pathway or outcome quicker. It saves costs, it saves lives, it saves staff. And so we were really, blessed to have worked very close with these guys, and they were doing such tremendous work. And I can remember actually in one of the lectures that one of the gentlemen was doing, he actually said the overall goal was, let me try and get this right, it's not verbatim, so I apologize to George, but it's that the overall goal was for them to be able to collect the collective intelligence of every radiographer in the entire world that has a knowledge of every rare disease as well as every other MRI scan output, and be able to put it into a little box and into a model. So regardless of where you went for an MRI, that could be in the middle of California, Sacramento, or it could be in the outback in Wales in the UK, you will get exactly the right person looking over your MRI and being able to make an instantaneous decision. Now, the difficulty with that is you then land with ethics. Is that correct? Should that be right? But actually, if you twist it around a little bit and say, well, actually, we certainly in the UK, and I suspect it's worldwide, we have a shortage of radiographers. Not many people grow up, in school today wanting to be a radiographer. It's not on the curriculum, and so this isn't to replace that. This just helps that workload. So, for instance, it generally the decisions today are often put in three categories. I've gone in for an MRI. It sees a problem. It sees what it is pretty sure is a problem that needs real investigation. It's not sure, or it doesn't see a problem. And in reality, they're not sure, or I don't see a problem. They will still go to a radiographer. A human should still see that to double check it, obviously. However, if it does see a problem with a degree, of confidence, why not take it straight to the next step? Why wait in that waiting list for a radiographer to look at it, and just take them straight to the consultant that's going to overview? Yep, this really is a problem, and we're going to start, some treatment. So we were fortunate to be involved in the early trials of that, and also the development of something called Mon AI, and that's become KCL started this, Professor Sebastian and his team, and that's become a world standard open source adopted by NVIDIA. Because prior to this time, and I don't want to elongate this much, but I remember doing some work and we looked around the world, and at that moment there was something like 450 individual healthcare AI projects, all doing something similar, but none of them shared data. None of them had anything in common. They were all their own teams doing their own work. So Mon AI was created to make a common operating system almost for the hospitals. So it gives a basis that then the individuals can write their projects on top of it, which means as we move forward, that there's a common framework that will allow every hospital to, in some way, interact and gain from each other, even if they're not sharing data.
It's interesting that to hear you speak, because what you're saying is, I think, something we don't hear all that often in tech generally and in AI specifically, which is that you're starting with the application, with the use case, with the need,
Hmm.
rather than starting with the technology. You have
Yes.
the basis in technology, but you're saying, first, let's think about how this is going to be used, what it's going to be used for, how will
Hmm.
it benefit people. This is such a contrast from
Yeah.
what we are hearing in popular culture about AI, the explosion of generative AI apps and chatbots and so on. I think the biggest criticism of most of that is that people are not doing what you're doing. People are
Mm.
not saying, what is this technology for? What are we trying to achieve? And how can we achieve that? And instead, they're saying, wow, this is cool. How can we push this further and further and further to
Yeah.
do something? And also everything you're talking about is very much not chatting with a large language model. Now,
Yeah.
that could be one of the tools you're using.
Hmm.
But again, AI applications and productive AI applications, especially at the edge, as we heard about when we talked to Nature Fresh Farms and how they're growing tomatoes with AI, the stuff that you're doing is a completely different world, and it's
Yes.
it's really refreshing. You know, how do you bring technology to the problem and vice versa? And how do you avoid that sort of irrational exuberance for such cool, fun technology as generative AI?
So no, that's actually a really good question at many levels, because that was one of the big learning curves for me, because clearly, as I said before, I've spent many years in IT and storage, and most businesses, me included in previous storage companies, what we tend to do is we think somebody like me designs what we believe is the next generation. We do that in stealth mode, then we launch it, and then we go out and evangelize to everybody why they need it. The strange thing is when we came to AI, and everybody, every vendor did pretty much the same things. You need this to make your AI go faster and better, a better return on investment, all the things. And yet you got to the professor and you went, I don't understand you, and I don't need you, and I don't want that at all. All I want to do is solve A, B, C. And what was really refreshing, I suppose, when you get to my age, is it was actually the first time where the market was so new, it was so at the edge that nobody really knew where it was going to go, and still don't today. We still get surprised by some of the outcomes. And so I initially sat down when we were trying to work out what was going wrong with storage as we had it at the time. And I can clearly remember some of the early conversations with some of the universities that were doing some really pretty cool work. And I remember saying, okay, we're involving two DGXs here. How are we going to deal with the storage? And they genuinely turned around to me and says, what do you mean by storage? Because they were looking at this as a problem, and that specific problem was a medical one again, where patients who had given birth on a Friday, if it happened to be over 5 o'clock when the doctors had gotten home, they had to wait till Monday to determine whether or not their baby had a problem, a particular type of problem, because only the doctor ran that test. And so the clinician was saying, hey, this makes no sense. We could just use AI to do this. Yet he had absolute no understanding of IT, didn't want any understanding of IT. He just had a problem and a bunch of tools that could probably make it work. So it was refreshing, going back to the question, to actually not tell the market what they need and have IT people waiting for you to give next generation, but to actually have a market saying, look, we need this to solve this problem. And A, that's refreshing, and B, it's just a lot more fun because you're doing some. We've spoken a lot about medical, but as you know, Jeniece, we've worked a lot with the Zoological Society of London, and that was just an amazing project because that's dealing with real life, worldwide conservation of animals, and to see the impact that they are making and the ability that AI, who would have thought AI would help them regenerate what were extinct birds and slowly build back populations or keep control and help the growth of populations that are slowly dying out. But by having the ability to analyze data and see trends in data that was just not possible before, they can run through so many scenarios that allows them to create conservation plans that we would never have been able to do before. So really, Stephen, this has been an eye-opener for me, but really a great eye-opener, because for once in my life, this isn't about, making a company make more profit or run that bit faster or be more productive, which is all excellent and very important. This is actually, the outcome is something that makes you smile often.
I couldn't agree more, Mark. I mean, the ability to, save the hedgehog, as we've talked about before, right? Or look at the ecosystem and the patterns of that, adorable little animal, right? Is something amazing. And you're giving those researchers such more of an advantage to do so, right? So we were talking about the London Zoo project. You guys were utilizing, I think, I'm forgetting the exact server, and I apologize. Um, but we populated that server with a bunch of 122 terabyte SSDs. And tell us a little bit about what did that do for that particular researcher?
What was interesting on this, which is, this is something again new. If you look at traditional IT, people have data centers. They've got nice cooling power and racks and everything you need. London Zoo had an old office that they put a rack in, and it was an NVIDIA, maybe two NVIDIAs, as I'm trying to remember now, DGX H100s, and they pretty much sapped every bit of electric power that office could deliver, because it isn't a data center. But they've needed immense amount. I mean, if you imagine that they're doing worldwide projects of animal traps, footage of every tiger and every lion and everything, every hedgehog that's out there, the immense amount of data that they have. So they needed to get petabytes of data, but they had no power. So without Solidym's actual real high capacity drives, we were not able. We just could not make this work. And there's a sort of a bit of a funny story on this one, because what we don't realize is, with power comes cooling. Well, with power comes heat, which means cooling. And in their case, they actually had to build like a refrigerator on the outside of this office block, which was right next to the water buffaloes, I think they were, the Chinese water buffaloes. And they actually, the noise that this made, they actually had to relocate the actual Chinese water buffaloes as while they actually installed all this. So the implications that this has on normal people that are using normal offices to do really remarkable things actually has taken a lot of technology. And you can't just go in there with the age-old approach of just putting a lot of storage in. We had to get the immense amount of petabytes in about 4U. And deliver a tremendous amount of performance so that they could train these models and learn from these. And on a serious side on that, they're only just beginning to realize what they can do with it. Because prior to this, one of the things they do, if you think about a camera trap that you often see on TV, it takes photos of animal, anything passing. They generally run this through an application first that gets removes anything human-like, or a picnic table, a car, a human, a kid, a ball or whatever, so that you end up with an image that's hopefully got an animal on there. Prior to this box, they could do something like 3 a minute, I think it was. That's what their server would do. After this storage and the Solidigm drives, etc., they could do something like over 1,000 a minute. So now what they can process, now they've suddenly got those images, now they're beginning to learn what they can do. And just as an example, and I know we were talking earlier, I know the hedgehog is not it's not a native in America, but in the UK, we grew up with hedgehogs. Everybody had one in a back garden, just transiently mooching around. Now you rarely see them. And if you think about it, we've urbanized everything. We've got roads everywhere. Nobody's got much grass in the gardens nowadays because they've got parking. Hedgehogs can't get across a bypass to get to another hedgehog. So they're interbreeding, they're not mixing, the colonies are getting smaller. And so they're beginning to use things like AI to actually be able, so when they get permission for new developments, they use AI to develop pathways for hedgehogs to be able to mingle as they always did do, yet still allowing us to urbanize and to move forward. Now you take that to India, and the tigers over in India, they know every single tiger by its pattern. So they can recognize that within a millisecond, no matter what. If that, unfortunately ends up on a rug somewhere, which hopefully it never does, they know exactly where it came from. And so what that will end up doing, which is fundamentally a small rack in an office, is changing, wildlife around the world. And we're still learning it. We're still seeing what their next challenge is. Now they can do all these images. What did they do next? And how did they deal with these? So, they're going worldwide, and they're opening that service over to, conservation experts around the world. But it's quite amazing to be involved in and to see the results of something so small, but yet so big in its impact.
When you mentioned the hedgehogs and you said they're using AI, I pictured hedgehogs using AI.
Yeah, tackling away there.
But to be honest, not, it shouldn't just be researchers in the ivory tower using
Mhm.
AI. Now, it probably shouldn't be hedgehogs, but it
Yeah,
should be everyone doing tasks that should be able to use this.
yeah.
One of the exciting things that I'm seeing in the AI space is an explosion of, I guess you could call it open source. They call it open source in
Hmm.
many cases, even though maybe it's a different type of thing, but just open science, open development, open applications, catalogs full of models. Again, sort of refuting the challenge the challenge that's thrown at AI sometimes, that it's just a bunch of chatbots and they're just getting better
Hmm.
and better, and all you're trying to do is burn down the rainforest and make a super mind. It's not like that at all. These
Yeah,
researchers can go and they can benefit from each other's work. They can go to a conference and learn about how an image recognition model is able to recognize tigers by their stripes. And somebody else in some other place could say, well, I'm looking at sharks and they have distinctive patterns as well. I wonder if we could use this same visual model. And similarly, on the hardware and software side, people saying, how can we leverage this technology in another area? That's what makes this whole edge space so interesting too, is because edge is fundamentally a world of constraints.
hmm,
It's not unconstrained data center where you have an acres and acres of ultra high performance servers. No, this is, as you said, the building next to the water buffaloes, and we've got to figure out how we can deploy servers in there that can do the task that we need in this location without just destroying everything.
exactly.
And in a way, I find that positive, because when people are faced with constraints, they tend to come up with novel and interesting solutions. When they're faced with no constraints, they tend to just burn everything, right? You
Yeah,
tend to just like turn it all the way, turn it to 11.
yeah,
If it only goes to 1, you have to figure out how to make it work. And is that your experience kind of trying to deliver these solutions in those
yeah.
environments and those edge environments?
I'm becoming more so. And again, one of the products that we've been working with Solidigm on uh, over possibly the last year or so, is when we started PKO, we realized that what we needed to do was deliver six times the performance in a sixth of the space with a sixth of the power consumption. So we did that, and we did that because that's what the labs and that's what the people and the users demanded. That it wasn't because they were, they didn't want to spend the extra money, which often helps, but it was because they simply couldn't power it. And if you look at the way GPUs are going now, a new GPU server probably takes, I don't know, 14 kilowatts. That's a tremendous amount of power. And I think I saw a statement not so long ago by Jensen saying that he can see a time when every data center has a mini nuclear system, nuclear power plant. I mean, that's scary, right? And one of the things we've been starting to work on, and likely just about to announce, is an extension of something we call Apex Drive, which will actually enable us to save 50% power on the NVMe drives themselves. So that's, if you're talking about an edge, that's not so significant. But if you start talking about a lot of the GPU as a service providers, that are those that are stimulating a lot of the inception, the new starts, the incubation, they've got thousands and millions of these NVMe drives. And if you can save 12 watts a drive, that's a significant amount of power, cooling, carbon. And so it is, it's almost the opposite of what we've always done, which is we've always had space and room. And so, when you want to go bigger and faster, you just add another thing in, just add another widget and it goes faster and everybody's happy. Take away that space, take away that power, and only allow you to turn up to number one. You've got to innovate. You've got to say, actually, how do I get where they need it to be, but I can't turn this up to two? I've got to stay at one, so something has to get better. And that, in many ways, is being the interesting part of our journey. Is although we've had software technology that does similar things for the last 20 years plus, we've had to scrap many of it, which is disappointing since you wrote it. But it's actually because that would have took us to 7, not 1. And now when you've got to get 1, you've got to get closer. Now the advantage is you've got superstars like Solidigm who are doing most of the work for you. And I know most of the storage community will probably hate me for this, but storage is, me included, we've lived on smoke and mirrors for the last few decades. We've generally lived on, somehow we do witchcraft. We convert these drives that you don't want to know anything about and they're not really intelligent, and we make them work for you magically. But the reality is most of the work is, over the last decade has been on that NVMe side. Solidarity have done the work. All we really need to do, we don't need witchcraft. We're just going to make them work for a user. So we've got the advantage that everybody, I think, also related to your open source analogy, it's in many ways, it's the same with the hardware. If we truly don't hide and try and disguise everybody's contribution, then collaboratively we can all create a better solution. If we acknowledge the advanced nature of Solidigm and use it what it is, and don't pretend anything other, then we make a better product. When we start adding smoke and mirrors and coming up with cool names and every other way that we can think of marketing it, we just create confusion and proprietary solutions that are taking us away from what the new world needs. Now the enterprise space isn't going. That's there. HPC space isn't going. But AI and GPU workloads, that's a completely new market and probably the largest technological shift that I've seen since the day of the personal computer. I can remember sitting looking at a personal computer thinking, what would anyone want one of these on their desk for? Until I saw, WordPerfect or whatever it was in them days. And, now it's the same with AI. It's the most significant shift I've ever seen. And it's time for vendors to stop trying to do it alone and trying to create proprietary solutions and their own standard and only their value. It's about collaboration now and for the better good of a movement.
Wow. That is a great way to end the discussion, I think.
I think we should stop there. That was amazing. A lot of good detail. Thank you so much for the examples. We are, we are delighted to have you here today and to have gone through the level of detail with Peak is eye-opening. And I'm a big believer in your organization. And after talking with multiple customers, I'm excited to see where Peak will go into the future. But why don't we tell the audience, though, where can folks learn more about your organization?
For those of you that have maybe just seen, we've been at GTC over with Western Digital and yourselves. So other than that, we're usually around in a lot of shows, but just visit our PKIO.com. And I'm over on LinkedIn with a name like Klarzynski. You can find me. And I think, which is what is pretty obvious, is, even though I'm the founder, I'm still passionate about what we're learning every day. So, if you're a user and you really want to get in touch and you want to influence what we're designing, reach out to me.
That's great. Thank you so much, Mark. And thank you also, Jeniece, for being part of this conversation. And everyone else, thank you for listening to this episode of the Utilizing Tech podcast. You'll find this podcast in your favorite podcast applications as well as on YouTube. If you enjoyed this discussion, please do consider leaving a rating and a nice review. We would love to hear from you. This podcast is brought to you by Solidigm and by Tech Field Day, part of the Futurum Group. For show notes and more episodes, head over to our dedicated website, utilizingtech.com, or find us on X, Twitter, Blue Sky, and Mastodon at Utilizing Tech. Thanks for listening, and we will see you next week.